let's discuss about load combinations. Definitely, our load combination should come from Eurocode because we are using Eurocode as our design code. Here, I'd like to explain a bit these inputs here for you to be able to understand. So you should have an assumed soil angle of friction if it's not available from the soil report. These values should range from 30 to 37 degrees. All right. And note that I have K sub O here. K sub O is basically the coefficient that you need to multiply to capture the lateral pressure that's acting on the wall due to the presence of soil, whether it's saturated or dry. All right. And I have two cases. Just ignore this value over here and let's just focus on the persistent one, because for the sake of this presentation, we will be ignoring accidental actions. So this highlighted area over here is where persistent is. So in Eurocode, you have two sets, one accidental and one persistent. We'll be focusing on the persistent combinations, right? So this value is over here. So these values for permanent and variables, in considering angle, shear of resistance over here will be used for us to be able to come up with our load factors. Note that these load combinations, it's actually very it might look weird to you because normally our dead load is 1.35, our live load is 1.5 in Eurocode. For American code, it's 1.2 and 1.6 for dead load and live load respectively. But what makes it complicated, that's why you see less one number here, is because I have multiplied it with the coefficient, this case of O here, coefficient, soil coefficient, whether it be active or passive. I multiplied it by this value so that later on, when I apply it in the model, I will just be focusing on the loads or the pressure that's acting on the wall because it's already included here in the load combinations. I hope that's pretty straightforward for you. And yeah, so let me just explain what are these conditions here: dry combinations, wet combinations, and one is full of water, one has an empty tank. Okay, for you to be able to understand this clearly, let's just focus on this very simple sketch. Let's assume that this is the groundwater level, right? And this is this water tank here, not water tank, PST tank here. This is the groundwater level. In other words, the groundwater level reaches up to the ground level. So the soil itself it's already submerged. You will have here a saturated soil, right? And that one is considered as these wet combinations over here. For the second diagram, this is the PST tank. Notice that the groundwater level is just exactly at the base. It means that all the soil on top of this one will be gamma dry or dry soil. You'll be using gamma dry for computing the acting pressure on the wall. All right, and that's what these two load combinations are. All right, and under these different combinations, I still have some different cases in them. All right, for example, the first dry combinations is full of water. In other words, the tank or the PST tank is full of water, but it's dry. The other one is empty tank. Okay, so for this one, the tank is emptied, but you have the water level just exactly at the base. All right, and then we also have GEO wet combination, still the same, full of water. We go on this set full of water, and the other one is empty tank. There's no water inside. And then one of the, I believe, worst case scenario is the leak test, no backfill, wherein this actually happens at the beginning of the project when you just build your in situ concrete PST or FST, and then you don't have backfill yet because you're going to do leak tests. That's, I don't know, maybe after 28 days after the structure or the concrete reach its maximum strength, or 28-day curing period or something like that. So basically there's no backfill around it. That's why, as you can see on this area, the earth pressure is 0. Okay, this values over here. And then the surcharge is also 0 because there's basically no surcharge around. And then the hydrostatic, definitely there's no hydrostatic in this area. So that's the leak test. And another load combinations that you need to develop is the uplift. This is very important and it's also very critical. Uplift is basically the sum of all the vertical loads considering the onerous case. Okay, when I say onerous case, this is the case where the uplift is so high and your vertical loads, the gravity loads, is minimum. When is it that your vertical load is minimum? That's when you have no water inside the tank, right? And then your earth pressure, or you're considering this case over here where the groundwater reaches the ground level, so it's fully saturated around and you have a very high uplift pressure at the base, and you don't have water inside that resists basically the pressure, the uplift pressure. That's the worst case scenario for the uplift combination. Okay, I hope you understand this load combinations, so don't be confused. You can create your own load combinations. This is basically the case. Don't be confused. This is the factor of safety. This is the case for the SIDL furniture, and so on and so on. And this is the load combinations, right? Okay, so now we are going to reflect these load combinations in the model. Okay, so here is the model. To be able to reflect the load combinations in the model, there are many ways to do it. For example, if you're a beginner, you can go to load combinations and then combination table. Sorry. Sorry, I should have done the other way around. Loads and then manual combinations. So if you press manual combinations, it will ask you what type of combinations. So for example, the first one is ULS, right? So ULS, and what is the combination name? Let's say combination 1. Just an example, combination 1. And then hit OK. And then here, it will ask you what are the cases that you need to be inside that combination. So basically, if you hit this value over here, you can press Control just to be able to select the different load combinations, right? A surcharge, hydrostatic, water sludge, just an example. And these are the different factor. So for example, if you choose 1 and then press here 1.35 and hit enter, it will go there inside. And then, for example, surcharge load, let's say 1.5, and hit press this arrow here, it will go inside. So that's basically how to develop a load combination and hit apply. This is just for the sake of presentation again, and then close. That's how you do it manually. And then there's another way to do it. It's very quick and very simple. And these load combinations over here, what you see that I've developed in Excel form is very helpful, because I'll just copy this one and migrate in RSA. Okay, how to do it? Let's go back to our model. You go to load and then hit combination table. And here you will find the load combination that I've just created, but we don't need this one because first it's not accurate. Just did this for the sake of giving you an example. Okay, so always click on edit here, just for you to be able to edit your load combinations. And then delete this one over here, just cut. So as you can see here, you've got combination, name, case, name of the combinations, what's the case, and the coefficient, case, coefficient, case and coefficient, so on and so on. So if you notice, the load combination that I have created here is basically the same format in our robot structural analysis. So here is the combination number, but later on you will find that this will be it won't follow this combination number. It depends on what number you stop in creating the load cases in your robot structural analysis. This is the combination name. This is the case for self-weight. This is the case for furniture. This is the case for earth pressure. So basically the case is just a number. Okay, if you go back to your robot structural analysis again, and if you hit this one, this is basically the number. The case is just the number of the load cases. So for example, self-weight, it's got a case 1, furniture 2, earth pressure 3, and so on and so on. So now what I'm going to do is I'll just copy this one because it's got the same format, right? I'll start from here up until there. I will not follow this because it's just for me to be able to understand well what are these load combinations. Copy and then go back to the model and then just hit or Control V, and there it is. So these are your different load combinations. Okay, and it's the same as the one we copied from Excel sheet. And just close this one, or you can just go to values, and this will give you basically an overview of what this load combination is. For the dry combinations, you have these definitions over here. Now if you want to edit this, another thing that you notice is these ULS here for SLS. It is wrong that this is ULS, but it's got no effect in it. But that's actually what happened when we try to migrate a load combinations from Excel sheet form, right? But it won't affect the results as long as you know what's your SLS combinations number, so that later on when you show some results, you know what load combinations you're going to pick to show to show the different results. Okay, so that's it.